Namaste. Welcome to the video lecture series on the chapter Periodic Table and its Variation. In this video, that is video number 4, we are going to discuss one more periodic property that is known as electron affinity. That is known as electron affinity, which is in short represented with the letter EA, which is in short represented with the letter EA. So, let us understand what's the meaning of the term electron affinity. So, basically, it's an amount of energy released. It's an amount of energy released whenever we add extra electron. Whenever we add an extra electron to the valence shell of an isolated gaseous atom. So it's basically an energy released whenever you add an extra electron. So generally, let me take one simple example to understand this. So I have a chlorine atom, atomic number 17, electronic configuration 287. Now chlorine has got 7 electrons in its outermost shell. So it tends to gain an electron. So it gains 1 electron and completes an octet. That means it attains the stable electronic configuration of nearest noble gas, that's an argon. But in doing so, it gets converted into negatively charged ion because number of electrons are more than the number of protons. So here, this gets converted into negatively charged ion. Now, whenever it gets converted into negatively charged ion, along with that, a certain amount of energy is released. And this energy which is released, that is referred as electron affinity. Now, as you know, the energy is released during this particular process. So, this is considered as an exothermic reaction. Now, do note one point. Your electron affinity is not reverse of ionization potential. See, in ionization potential, I am providing energy to eject the electron. Now it is not same like if I remove the electron, I provide X amount of energy, and to add a electron, same amount of energy will be released. That is not true. Okay, so do remember that your electron affinity is not reverse of your ionization potential. Now, next we discuss on factors. About the factors which affects electron affinity. So very first factor which we have, a nuclear charge. That's a nuclear charge. So if nuclear charge increases, electron affinity increases. So if nuclear charge increases, electron affinity increases. So atom will tend to gain electron very quickly. Second factor, that is atomic size. If atomic size increases, then electron affinity will decrease. So larger atom do not tend to gain electron very quickly. That's why less amount of energy is released. So do remember one particular fact. If gain of electron is very quickly, then more amount of energy is released. But if the atom do not gain electron very quickly, then less amount of energy is released. Do remember the fact, if an atom gains electron very quickly, then more amount of energy is released. But if an atom do not gain electron very quickly, less amount of energy is released. So that refers to your electron affinity values. Now, how the electron affinity changes. So we are going to look into the trend of electron affinity from top to bottom. So first we are going to discuss about down the group, we can say, how the electron affinity undergoes change as I move from top to bottom. So for our understanding, I am taking one of the simplest and known group of the periodic table, that is 7A group. So let me take a 7A group or 17 group. So this is group number 7A or 17. Now the element which are present in this particular group are your fluorine, chlorine, bromine and iodine. So the element which are present here is fluorine, chlorine, bromine, iodine. Now let me draw the nucleus of fluorine. Let me draw the nucleus of fluorine. So this is nucleus of fluorine, this is nucleus of chlorine, this is nucleus of bromine and this nucleus of iodine. Then I draw the shells. Fluorine has got 2 shells, chlorine has got 3 shells, bromine has got 4 shells and iodine has got 5 shells. Now each of this has got 7 electron in its valence shell because they are present in 7A group. They are present in 7A group. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now as you can see from top to bottom, every time the electron is added in new shell. So as I move from top to bottom, the atomic size increases, hence in general electron affinity decreases. So here I can say small atom gains electron quickly. Okay, so releases more energy. Okay, whereas if you have a large atom, do not gain electron quickly, so less energy is released. Okay, so as you can see from top to bottom in general, with increase in atomic size, the electron affinity decreases. So smaller atom tend to gain electron very quickly. Larger atom do not tend to gain electron quickly. So if atom is small, more energy is released. That means more electron affinity. Atom is a large, then less electron affinity is been observed. Now this is in general trend. Now here we have one specific thing to study, that is with reference to fluorine and chlorine. Although we have discussed here that electron affinity value of fluorine is more than that of chlorine. Electron affinity value of fluorine is more than that of chlorine. That is in general trend. But actually in practice, we do not see this. Actually in practice, we observe that electron affinity of fluorine is less than that of chlorine. Now why is it so? Why the fluorine, which is having a smaller size, should have more value of electron affinity, but here it is seen that the electron affinity of fluorine is less than that of chlorine. Now just look at carefully. Now fluorine, as we have mentioned in above, it has got 2 shells, so the space is very less. Now due to this, what are the electrons which are already present in those 2 shells? they generate a strong repulsion between them. So in a smaller space, which are the electrons which are already present, they generate a strong repulsion. So due to this, the incoming electron does not feel much attraction by the nucleus, because nucleus is busy in controlling the quarrels between the two electrons. Whatever the paired electrons are there, in between them, whatever the repulsion is there, nucleus is busy in controlling that. So he doesn't pay much attention towards the incoming electron. So incoming electron is waiting outside the door to get in. But as the nucleus, who is the head of the family, is controlling the quarrel, he does not pay attention towards that. As a result of this, the fluorine has got lesser electron affinity. The fluorine has got lesser electron affinity. But when you take a case of chlorine, now it's not likely that in case of chlorine, the quarrel is not taking place, the repulsion is not taking place, but chlorine has got more size. Okay, chlorine has got more size. That means it has got 3 shells. So what it can do, the quarrel is there, but it can readily accept electron. So it can accommodate that additional electron very easily. It can accommodate that electron very easily. Now due to this, as it can accommodate electron very easily, due to that large amount of energy is released when chlorine gains electron. That's why electron affinity of chlorine is more than that of fluorine. Electron affinity of chlorine is more than that of fluorine. Okay, hope you must have understood this. Just keep a concept: a nucleus has to pull the extra electron, a nucleus has to pull electron inside. But if suppose nucleus is busy in controlling the repulsion between the existing electrons, it cannot able to pull extra electron easily. That's what happening in case of fluorine. That's what it's happening in case of fluorine. Now let us move further towards across period, how it changes. Now as I move from left hand side to right hand side, so let me take a third period of the periodic table. So I'll take third period of the periodic table. Now which are the elements which are present in third period of the periodic table? Please do remember that, it's very important. I have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. And argon generally do not take up any electron, so we need not have to take that into consideration. So this is 281, 282, 283, 284, 285, 286 and 287. So let me draw again the nucleus of sodium, and this is the nucleus of chlorine. Then the number of shell: 1, 2, 3. 1, 2, 3. Then the electrons. Now sodium has got 1 electron and chlorine has got 7 electron in its outermost shell. So 3, 5, 6, 7. Now if you carefully look at, okay, as we move from left hand side to right hand side, with increase in nuclear charge, the nuclear charge is increasing, the size of an atom decreases. The size of an atom decreases. So here I have a sodium atom, larger in size, and this is smaller in size. So larger in size do not readily gain electron. Here readily gains electron. As it readily gains electron, more energy released. As it do not readily gain electron, less energy is released. So low IP, high IP. So from left to right, your electron affinity value goes on increasing because the size of an atom decreases. Now let us focus on one of the important parameters which can be asked as a give reason. Why do noble gases have got electron affinity value 0? So noble gases have got 0 electron affinity. So why is it so? Let us look into that arrangement. Now let me take few noble gas like neon and argon. Neon atomic number 10, argon atomic number 18. 288, and this also 288. If I take a helium atomic number 2, okay, so it has got electronic configuration 2. Now if you take a case of helium, it has got duplet completed, neon has got octet completed, and argon has got octet completed. So all your noble gases, that is helium, neon, argon, krypton, xenon, radon, they have either duplet, like helium has got duplet completed, and rest all gases have got octet completed. Now this to have octet or duplet is a condition for stability. It's condition for stability. That means I can use another word also for this. They have a stable electronic arrangement. They have stable electronic arrangement. Now due to this stable electronic arrangement, they do not show any tendency to lose, gain or share electrons. So they do not gain any electron. So there is no scope for an addition of any extra electron. When you don't have any scope for addition of extra electron, no energy is released. Hence their electron affinity value is 0. Their electron affinity value is 0. Hope you must have understood this. Thank you for watching.